Thank you. Thank you.
All right, so it's 3:30. And again, can someone help us with the note taking while we?
Thank you.
Thanks, Joe. Thank you very much. Cool. So
Let's get
rock and
started.
roll.
Yeah. Go ahead.
So hi everyone, my name is Juan Carlos Zúñiga.
Hello, everyone. Wasim Haddad here. Welcome to INTAREA session.
Thanks. So as usual, this is an IETF official meeting. So we have the IETF policies in effect um, for topics such as patents and code of conduct. So if you participate in this meeting, you agree to follow our processes and policies. And you're aware that your contribution will be covered by patent applications that are owned or controlled by you. You must disclose that. You acknowledge that all written audio, video, photographic records we may be made public, and the personal information that you will provide will be handled in accordance with the IETF privacy statement. So very importantly, too, you agree to work respectfully with other participants. And if you have any issue, please contact the Ombuds team at the address provided on the slide. Uh, there's also information on the BCPs if you have more questions, and you feel free to reach out to the working group chairs or the area directors. Sorry? Okay. Okay. So we'll do like this. Thanks. All right. So next slide. For the note really well. So all this is on professional collaboration. So if ever you see any harassment or misbehavior, please report it. We at the IETFs try to create and maintain an environment for people with different backgrounds to collaborate and work together. So we please ask you to treat everyone with dignity, decency, and respect. And again, you should not engage in any harassment while in the meetings. If you believe you have been harassed, please let us know and contact the right people. For the meeting tips, as usual, we're doing a Meet Echo. That's how we're keeping track of who's attending. So please log on to the tool, either with your mobile phone or your computer. And that's how we are going to be keeping track of the queue and your participation. These are the resources, agenda, Meetico, and if you need assistance, please reach out. Okay, so agenda. Let's bash it out. So we have the status updates as usual from us. Then we're going to have Tommy and co-authors. Okay, Togan, you're going to present on the proxy provisioning domains. We have Probe with Bill, as well as extending ICMP, stateless reverse root, trace root from Valentin, Savvy with Lynn, web proxy auto discovery, Josh, ICMP extensions from Yan, and EVN6 from Chongfeng. Any questions or comments regarding the agenda? All right. So the first working group item is the communicating proxy configurations in provisioning domains. We'll get an update on that from the author, so no need to discuss much right now about it. The biggest update that we wanted to give you is about the expired drafts. We have a big list of drafts that are expired, and after discussing with our AD, we believe those should be declared dead. So that they don't still hang and stall there in our page. So we're going to be reaching out to each one of the individuals, authors from those drafts before declaring them dead. And of course, they will be free to bring them back to life even after death. That's one of the superpowers of the IETF. So but for now, we just think it's the best thing to do. So if ever you are one of the authors and you want to mention something about them, feel free to do it now or on the mailing list or reach out to us. I think that's about it for the working group status updates. Any questions or comments? No, hearing none. So we're moving to the first item, communicating proxy configurations in provisioning domains. Nagma. Can you share from there? If you choose share slides, we just uploaded them. So share slides. Yep. It doesn't tell you which one.
I granted you access. Yep, it's coming.
And then
Here we go.
you can control.
Hi, everybody. I'm Draga Mijaic from Microsoft, and I'm going to present the update on the draft communicating proxy configuration in provisioning domains. I'm co-authoring this draft with Tommy Polly from Apple. So this is going to be a really short recap what the draft is about. So it's used provisioning domain JSON format from RFC 8801 and add supports for proxy configuration. There is a couple of proxy configuration parameters here. And one of them is, for example, is a proxy protocol supported by the proxy. It is very funny to say that. So if the client is configured to use a proxy, for example, HTTP Connect proxy, it can ask for a provision domain for that proxy using the well-known URI and can find out about other protocol, proxy protocol that protocol supports and can upgrade to the better version, the more secure version, for example, Max proxy. It can also, in the same way, find out about configuration the proxy has, for example, which domains are allowed and which domains are not allowed. And also the draft shortly explained that proxy can be also, proxy configuration can be found out or learned from the network. But in this case, there is a security issue or security consideration attached to it because clients should not blindly trust data that are coming from the network or information that are coming from the network. So there is some text about this in the draft explaining that there should be some kind of policy allowing to use these kind of proxies and not just blindly use them. So the status of the draft was adopted since the last IETF, and we also have a short update that address some of the major issues that we had, and I'm going to go through the updates, and we can discuss or have a feedback from the group on them. So this is the list of the updates, and I'm going to go through each of them one by one. So the first one is we added configuration information about the HTTP version supported by the product by the proxy. So before this update, the client didn't know what version of HTTP proxy supports. So it could only use the regular way of finding out the versions of the HTTP that is supported, for example, racing them or trying and falling back, or using something like service B DNS records, which doesn't work in all the cases, for example, if it's connected to the address. And also it can use alt service mechanism to learn about the HTTP versions, but this adds a round trip time to find out. So we added a new key. This is LPN key, which contains the list of LPNs that proxy support. And in this way, the client knows in front which version the proxy support and can choose the one that best fits their needs. Any questions or feedback on this?
Thanks, Dragana. Ben?
Ben Schwartz, Meta. Uh, I'm not. Oh, all right. I'm not convinced that optimizing connection to HTTP endpoints that use an IP hostname should be a priority here. I'll note that it is not a priority. It was not a priority for the original service bindings draft, which does not attempt to cover that. It just says that's going to be slow, and and that's how it is. So I don't think it's really worth optimizing. But if you want to go down this road, I would encourage you to harmonize this with the well-known ECH draft in the TLS working group, which also specifies a JSON encoding for the same information.
Okay, yeah, I will take a look on that. Or Tommy?
Tommy Polyapple. So just responding a little bit to that, like in the case of like SVCB, given that's like on a DNS record, I totally understand why we would not try to address the IP literal case there. I agree it's a low priority in general, but I think you could imagine some funky cases where you have a proxy which is only available over H3, and it is only available by IP address in some weird case. And while we are already giving the configuration information, you may as well have a way to tell that, since there isn't another mechanism. This is just, I think we can change the syntax, absolutely. And if we have something better to look at, I'd love to do that.
Okay. Yeah, I'm not going to argue against this.
Yeah, we already have a configuration. It's just adding the new key to speed stuff up.
Yeah. Okay. Yeah, okay, sorry, I just want to add, extensibility is going to be valuable here because you might want ECH.
Okay, I will take a look at that. The next issue, the next update that we had is about the DNS, the split DNS configuration. So previously we had DNS zones keyword that was listing the domains that are allowed to the proxy, but this doesn't work it's not easy to configure excluded domains in this way. So now we have two lists. We have matching domain and excluded domain, which contains the list of domains. And client, when it wants to connect to their source through the proxy, so it's a domain to the proxy, it needs to check both of these to figure out if not proxies could route this request. Yeah.
Ben Schwartz. So DNS zones is defined in RFC 8801. The definition of it is completely opaque to me. I would really like to see, and this. So now this is going to end up with 3 different DNS domain lists.
The DNS zone is out, so there is just 2 of them. There is just matching domains, excluding domains.
So I looked in the draft. DNS zones is not mentioned, which means it's not deprecated, and the interaction.
No, this is in the subdictionary of the proxy. The
Okay.
proxy is a separate subdictionary, and for the proxy subdictionary, there is just 2.
Okay, that's helpful, but I think you still need to address the interaction between them. Maybe a sentence saying don't use DNS zones in this PVD. I don't know.
So everything, no head here. I just wonder whether the key names are correct, because you say match domain and excluded domain. Should it be exclude domain?
We can change the name. Yeah.
Tommy Polyapple. One other point that I had heard discussed, a question brought up by someone else earlier this week, was how do you handle match and exclude IP subnets? Because that is something like a pack file can do. So either that leads to more keys, or we find a way to have the format of this key allow for matching and excluding both names and subnets. It's just something that needs to be taken care of. I think it is important.
Yep.
Yeah, I think there's also a clarification to be made that exclusions, you could have only exclusions and have the default be include everything. To say, so there are no specific match domains, but you only have a little carve out for things you don't want to proxy.
And the last change since the last IETF is about marking keys as mandatory optional. Previously, we didn't have this identification for the keys, and now this should add a better way to support different use cases and different configurations. So all the new keys that I was mentioning before, like LPN and excluded domains and matching domains, are optional. And we updated the INR registry to add a column about mandatory, or to add a column mandatory. So this is this sufficient for the long-term strategy to be able to update and extend this configuration? Any thoughts?
Hi, Josh Cohen. I think one of the things that should happen is to look at the different functions that are commonly used in pack files. And that may mean more keys, or it may mean, like Tommy was saying, sort of rules for how to do it. Because I think things like regular expressions are commonly used in pack files. So stuff like that. So basically doing like a review of the different functions and seeing how, if possible, those can be added to PBD.
Yeah, thank you. That's a good feedback. Okay.
Sorry, I'm having a hard time getting into the queue. Mind if I jump in? David Skenazy, Google. Just to answer Josh, I think the fact that pack scripts were Turing complete was somewhat of a horrible mistake that's been a huge headache for decades at this point. So if you do, when you do this effort of looking at that, don't go crazy. Keep it
I know.
simple. This is what's great about this.
Yeah, I know. I know. We don't want to have the same thing, like the same security issues or similar ones, or any. So, and the last slide is about the remaining issues that we currently have, except that what Tommy was already mentioning on the this was the slides were made before that. So the first one is about authentication to the proxy. This question: should the configuration have also some information about what kind of authentication proxy expect? Not to perform the authentication, but a kind of authentication, so that the client can maybe prefetch some tokens that it's needed, or decide not to use the proxy because it doesn't have a proper token for this kind of authentication to the proxy. The second one is about the character set used for the JSON format. The provision domain JSON format doesn't restrict the character set to be used. And the question is, should we restrict it for this sub-dictionary for the keys and for the values to be able to easier parse them, yeah, in the different programming languages. And the last one is, as I already mentioned, the proxy configuration can be learned from the network, which should not be trusted completely. There is already some text in the draft about that this should be considered carefully. And I'm wondering if the working group can take a look and have a feedback of whether this should be extended or changed, or yeah, any feedback. Yes, Ben?
Hi. I really think that we have a lot of work to do on client authentication to proxies. I don't really see why it would go here. It seems to me that it would go in line with the normal HTTP authentication challenge response flows. We still have some work to do. The existing flows don't do it, but it's not obvious to me why it would go here.
This will be just a hint. More than the hint, it's nothing else.
Anyway, that's all that's the only thought.
Yeah.
On JSON, it happens that URI templates are defined as Unicode strings, and that is also what JSON strings are. So the most natural thing to me is to say nothing there. And all the other fields here are containing defined content. I think, you know, it so happens that all of the possible valid values are lower ASCII, and so I think that's covered implicitly.
Maybe the key values should be a string without space or something. It's just lazy, either parsing or something like that.
So you are defining a registry
Yeah.
for the key names, and
Yeah.
you'll have to come up with some rules for what those key names are. But I don't think that matters.
Yeah. Thank you. Schmidt? Mike?
So to Ben's comment about authenticating to proxies, for most cases, I agree with you that you should just have a URL, and when you try and hit the URL, you'll get challenged for authentication and handle that with the normal flow. I think the exception to that is possibly what David is now in queue to discuss. When you have a proxy that doesn't want anyone to know it's a proxy, and you're going to be presenting the unprompted or whatever we're calling it, this IETF auth scheme.
Luckily, I didn't get out of the queue. So normal HTTP authentication challenges basically don't work for proxies, and it doesn't really work, and it's effectively limited to your very most basic situation. So, like, for example, you can't return like a normal HTTP authentication. You can return a 400, I guess, and like present the user with a page that like guides them through some kind of authentication flow. You can send them out to do single sign-on somewhere else and come back. There's like stuff that you can do, but with a proxy, there's no user interface that you can display. And so, except for the very narrowest like situations where you want to do basic authentication or like something dead simple where there's a defined Chrome that the user agent can present to you, it doesn't work very well. So this is what I mean by we have work to do. I wanted to be able to do single sign-on and passkeys and two-factor through HTTP authentication to proxies, but I just don't see how that connects here.
Yeah, there is definite progress to be made in the field. I don't think any of that leads to we need to stuff something in this JSON.
David Skenazy, authentication enthusiast, I guess, person who filed the issue number 249 here. So the motivation for me there is that there are a bunch of authentication methods that do work with proxies. I mean, basic, sure, but mainly the ones like HTTP concealed auth that I'm the author on that just went through, like finished working group last call. Also all the privacy pass ones. And so in production, like we have these in production. And being able to know which of those your proxy supports as a hint can be useful because you have this constellation of stuff. Can be nice. So that was the intent of this. It's not to define any authentication to the proxy. It's just to say which authentication schemes does this proxy support. Yeah.
Jim Taft from Broadcom. I will say that authentication methods are heavily used in on-premise proxy deployments, Kerberos. And every large company I deal with, Kerberos, everywhere. So it is heavily used for 07 redirect to authentication.
Tommy Polyapple. Yeah, so to the question of auth, I mean, like, I don't really care too much if it's in this JSON format. But overall, I think for a lot of the proxy cases, if it's not in something where you're part of a browser, like it's just like something the system's doing, you need to have a case that's just like the machine is just automatically going to be able to present this. For a lot of the mass style proxies, we use privacy pass very heavily today. One of the benefits of having a hint here is that for some of these types of authentication, you need to do, or it's useful for performance to do work ahead of time. Like with privacy pass tokens, you can grab a whole batch of them ahead of time because you're going to do one-time spending on them. To the UI flow, one thing that we may also want to consider is grabbing like the PVD information is something that happens at the time of learning about the configuration of a network or a proxy and deciding, do you want to use it? And so that is potentially an opportunity for some system level or other configuration level UI where you can say, okay, I've learned that my proxy takes something like a credential that's derived off of another credential, so I can grab a privacy pass token that is based on the fact that I signed in with single sign-on, and so I can have some nice UI flow which unlocks my ability to later authenticate automatically. So just things to consider.
Okay. Thank you. So we close the queue, but thanks, Dragana, for the presentation. If you have any more feedback, please feel free to send it on the mailing list. So Bill, you have two presentations, 5 minutes each, so feel free to use your 10 minutes as you please.
Okay. Hey everyone, I'm Bill Fenner. I'm here to talk about two completely different ICMP things. So the first one, they're both actually, but the first one is one that came up first in Brisbane, and it's about the probe protocol, RFC 8335, also called ICMP Extended Echo. So this is a protocol where it's a lot like ping in that you send a packet to a remote and you get an answer back. But it's not at all like ping in that you are asking the remote a question. You're not just saying, did this packet get to you? But you're asking, is this interface of yours up? Does it have an IPv4 address? Does it have an IPv6 address? Or is this entry in your ARP cache or your neighbor discovery cache? So that's the background of what the protocol is. A reminder of what's the motivation for publishing a new document? I went to go implement it, and I did a survey of existing implementations and how they behave. And I'm not going to go over the details, but the fact that each implementation had a different behavior made me come to the conclusion that the spec needed some clarifications. Also at the bottom is a question from a user like, is this successful or is it not successful, and how do I know? So last meeting, I presented the document and a lot of the contents. The changes since the last meeting were very minor. Got some good feedback, but just kind of said, oh, like this optional field is really optional, and deleted the extra null in null. Really good stuff. The authors think that it's a valuable update to RFC 8335 and that it's ready to move forward. Some resources kind of for coming back to, I don't expect you to copy stuff off of here live, but there's some tools that I built while I was doing this exploration that like sends, using SCAPI, some probe packets, and my v4 pull request got merged into TCP dump. V6 one is still pending. And a repository to do some work on the open source probe client, and then a link to this document. So what's next? There's still the author issue. We can resolve that. I'm not worried about it. But I don't know if we are, if we should do, some informal interop testing to see if my ideas about what the spec now says are right. And then really the reason I'm here right now is, like I said earlier, the authors think that it's ready to become an RFC BIS document. So I'm asking for working group adoption. Anyone have any comments?
Well, jumping in the queue, no hat on, but for the interrupt testing, are you foreseeing something like a hackathon or You have something in mind that you want to the group to propose to the group, or?
I mean, it could just be, I have access to all of the implementations that I know about, so I could just set them up in a lab one day and start pinging and publish that result either as a, web page or as an appendix in the document or something. The question is, I mean, maybe there's a round of feedback to the with the implementation authors before making the results public because of those red X's,
Right. Right.
Thank you.
Okay, Eric Vink, as an individual contributor, yes, go forward. That looks like an interesting idea. Only thing if it's adopted and when it's adopted, change the name in RSC 8335, whatever bis, right?
Yeah, I didn't want to presume when I first published the work, so I didn't want to say, I know this is going to be 8335 bis. So when it becomes, if it becomes a working group document, yes, I agree, change the name. Thank you.
Okay. Yeah, so I think makes sense. So we'll consider it, but for yeah, exactly. So
okay, great. Next ICMP thing. Perfect on time. Okay, so this one is about the weird kind of deployments we're starting to see, customers are starting to talk about, where in a world of IPv4 scarcity, you don't want to assign a unique IP address to every interface, IPv4 address to every interface on your router. That's just wasteful. But you might not even want to assign an IPv4 address to every router. If all of your forwarding is done over IPv6, all of your control plane, you barely need it. You kind of need it for traceroute. So let's fix that problem instead. This is what I just said. So it's all about IP address scarcity and deployments that are moving to extreme reductions in the amount of IPv4 addresses used. The proposed solution is to be able to use this ICMP extension mechanism, which there are a number of different ways in which to use these RFC 4884 ICMP extensions, to be able to add an information chunk to an ICMP error on its way through. So the response to the traceroute could now include this, this field that says, this is my address. Don't really pay attention to the source address. That's not enough information to know who I am. This is who I am. And also a node name. So call me router foo. You don't have to, you don't have to do anything to learn more about it. That's who I am. So this is an extreme example of the very scarce addresses. Every node in the traceroute has the same address because we just ran out. And in fact, that's a bogus v4 address anyway. That's from the reserved space. But so this is just a format that could be used, but this is, each of these hops has a different piece of information. It says, here's my node names. Here, this one just says, here's my IP address, IPv6 address. This one says both. And then the final one just, again, back to just its node name. So the current status, we have an implementation in Arista EOS. Cisco has an implementation in the lab that they're playing with. Arista has patches ready to submit to open source TCP dump and traceroute packages. The IANET code point has been assigned, but we're not using it yet. We're using the mechanisms described in the experimental code points useful RFC that where you have to explicitly configure a private use code point in a test deployment. And we're doing that to make sure that the working group has the ability to change this. If we just ship something and use a code point, like we got the code point because it's first come, first serve. But if the working group decides that the document needs changes, then we just burned that code point unnecessarily. So, but for this, I wanted to mention also that there was some, I sent a message last week to the mailing list. There were some good follow-ups to that on the mailing list. So I think there is interest out there in this. So again, I say, for this document too, I think we're pretty ready for working group adoption.
Thanks. Joe?
You can go back to the recording.
Right, yeah. Joe Clark, Cisco. I've read the draft, provided some feedback, and I think this is fantastic from a troubleshooting standpoint. I mean, Bill showed an example, but you can imagine for operators, then anyone who's doing a trace route across the internet, this is useful metadata to see. It fills in gaps. And if I was the operator running the network, it would help me like, oh yeah, that's this address here, even if I didn't have everything in my own internal DNS. So I think this would be great. It feels like low-hanging fruit in the world of the internet to implement something like this.
Thanks.
Thanks, Joe.
Ben? Thank you.
Ben Schwartz, I'm definitely not an expert on this at all, but when I see trace routes, they usually have IP addresses, and then they have names derived from pointer records in the reverse zone, and that's it. Right. And this seems to recapitulate that basically. And I wonder, is this an opportunity to provide more user, human readable information beyond an IP address and a host name to be able to tell me something about this piece of hardware that might be useful for me to know?
There's an example is RFC 5837. I always get it backwards, but that gives you incoming interface information, which is another piece of information that you could get if every interface had a different IP address. But again, we're moving away from that. And so in order to fill that in, that RFC gives you incoming interface, IF index, or name and/or address and/or MTU. So it can give you any of these pieces of information. So that's an example of what already exists, and you could deploy these things together. These extensions are stackable, so you can have this one and that one at the same time. You don't have to worry about them conflicting.
Okay, that's interesting. I just for food for thought about whether you want this field to really be a host name or whether you want it to be a free text field.
Right. So I want it to be a host name, I think, because I don't want, okay, let me turn it around. I don't want a free text field. I want, if it's going to be more than just a host name, I want a structured text field. And I don't want to put JSON into ICMP. So, there are other bit fields available if we have some ideas about what further information is useful. There's also privacy implications, not personal privacy, but network design privacy. And the more information you give out, the more you have to worry about the privacy implications of giving that information out. And so that's another reason that this is kind of focused and limited in scope. However, I'd encourage a discussion on the list if anyone has a concrete suggestion about more information that would be useful to add.
Robert Kostek, IPNCC. One of those could be geolocation, just, passing comment. More to the point, in a different universe, we were looking at reverse names for router interfaces back in the day, and noticed that in many cases they are just off. The router was there, but now the same IP address is used somewhere else. So when you look at the reverse name in traceroute, it actually is lying. Fine.
Yeah.
So that leads me to the question, what is going to be the incentive for the operator to keep this updated? if they ever put it in?
It's being provided by the router itself, so it just says, what is my name?
Then the name is meaningful to whom?
But the name that you get in a normal trace route from a pointer lookup is meaningful to some subset.
And that's
I mean,
exactly my point. That can diverge from reality. So I don't know if that's could be a problem here, but what I'm looking for is that what is the mechanism to keep that information true?
well, I mean, in my mind, the mechanism is that it is provided by the router itself as opposed to something else. You know, the DNS is an indirect lookup, and so someone else has to update the DNS.
Right, but the
when
router
this
doesn't know its
changes.
name. It's assigned by some human, and that human needs to reassign that name if the router changes a place or behavior or whatever it is. So I'm still, I don't know if this can get out of sync with reality. If it can't, that's fine.
I mean,
accept that.
operationally, I feel like it kind of is very probable that people will keep their router devices. I mean, in a world where you log into a router to fix a problem, you really want to know what you logged into. And so its hostname will tell you. This is kind of the self-describing network model where the device knows everything about itself. And so this is what it's telling you. It's saying, I am the router called foo.
Okay, thank you.
Thanks. A lot of good feedback. So please take it on the mailing list if you have any more discussion. Sorry, we're cutting the queue because we just want to make sure we keep on track. So, Rolf, all yours.
All right, my name is Rolf. This is stateless reverse traceroute, and that's collaborative work with Valentin. And he was here during the Prague meeting, I believe, and he presented reverse traceroute. So the stateless was missing. And the comment was made that, and it's fair and it's true, that functions using ICMP typically don't keep state around. And we had the stateless design basically already ready. So we put it into draft format and uploaded it. So I'm basically presenting a tweak on something that Valentin presented, I think, 2 IETFs ago. So before I show you how we do it, I like to reiterate the why. So the problem is when you do a trace route, we talked about trace route already a little bit. When you do a trace route, you get a bunch of routers from you towards that destination. You see the forward path. And in addition to the IP addresses, and if a pointer record exists, the router names, you get round trip time measurements. And when you look at this, this path that is being traced, you might see that between routers C and D, the latency goes up and it persists. So it's not just at that router, but it persists. So it seems to be a problem somewhere. And just given this output alone, you might assume that there's something wrong between routers C and D. So at the handover point between network A and network B. And that might be true. You don't really know, but it might be the case that there's a problem. But you're doing round trip time measurements. So you also have the reverse path as a component in your round trip time estimate. So the time includes the forward direction and the backward direction, but you don't see the backward path. So the return path is invisible to you. And if router D, for example, decides not to route back through network A, but decides it on a different network for routing policy reasons or something else, then a problem between those two routers at the bottom will give you the exact same output. So from your perspective, doing the trace route, you don't know if it's on the reverse path, if it's between routers C and D. You just see that there's an increase in latency at some point. And I presented this at DNOC, which is the German version of NANOC. And 2 days before I gave my presentation, there was a request on the mailing list for somebody from a certain prefix to reverse trace route manually back to him because he sees a problem and he's not sure if it's on the forward path or on the backward path. And so today people fix this with personal contacts or mails, and that's a sorry state of affairs. So we try to fix this, and now I'm going to show you how we address the problem. So we define a new ICMP request and response. The ICMP request is to trigger a single probe packet from the server back towards you. So you basically have to send one request for every packet that goes out. You don't want to send one request and then have a whole trace route going out because that's clearly an amplification attack vector, and we don't want to have that. Now, what the server then does is in your request, you can specify what should be the TTL of that packet, what should be the protocol. So you basically configure regular traceroute remotely. And the operation itself is just what traceroute does today. It's exactly the same thing. So you can pick UDP, ICMP, or TCP as the layer just above IP. And you can also control fields that are typically used by load balancing routers, like port numbers or the checksum in ICMP packets. The server will send this. The server will get the ICMP time exceeded message back. And what's missing now is reporting this back to the actual requester. And that's the second ICMP message that we define in the document, which contains the IP address, or maybe at some point node names, and the RTT estimate. So it gives you the same information that traceroute gives you locally, but from the remote host. So I already said that we had the stateless version already at hand, but we consciously decided to submit the stateful version. And there's a reason for it. So stateless basically means we don't keep state locally. We put everything that we need to calculate round trip time, for example. We put it in the packet, in the pro packet we send out. And when we get the ICMP time exceeded message back, we hope there's enough information in there that survived so we can do all our calculations. And I give you ICMP here's an example. So for IPv4, the standard says the only thing that's guaranteed to come back is the copy of the IP header that expired, plus at least 64 bits after the IP header. It might be more, but the standard says it should be 64 bits. So when you look at an ICMP probe, the same applies to UDP. For TCP, it needs to be even more bits because the header is simply bigger. An ICMP probe sent out by traceroute would be an ICMP echo, which is type 8 code 0. We can't do anything about that. We use the checksum to adjust the behavior of load balancing routers. To set the checksum, we need to add some payload at the bottom, but that can be discarded. That's not a problem. We put the identifier in there. So the requester says, here's an ID for my request, and the response, it expects the same ID, so it can match request and response. We need to put it in there as well. The probe, I'm not going to go into that much, but everything there is guaranteed to come back because that's the 64 bits that the standard guarantees you to come back. And then we also need to add a timestamp when we send the probe packet, because when a packet comes back, we look at the time and subtract them, and then we know how long the packet was inside of the network, so the RTT estimate. That's not guaranteed to come back. So what it means for the stateless version, RTT estimations are not guaranteed to work. The question is, will they work on the current internet, right? So it might not be guaranteed, but the current internet might not behave like this. So what we did, we looked at some data from RIPE Atlas. So they give you the archives of the data. I think they give you metadata basically. And we went through roughly 200 gigabytes of compressed archives, looked at all the IPv4 ICMP time exceeded packets in there, and then did some statistics. So did first some filtering because there was bad data in there, and then did some statistics. So you see this in this table here. So roughly a little bit less than 50% actually sticks to the 64 bits. So in those cases, we can give the requester the IP address of the router, but we cannot give the requester the round trip time estimate. But that's really valuable. As a troubleshooting utility, you want to see that as well, right? So for 50% of the cases, you will not be able to calculate the RTT. But for the other 50%, you will actually be able to do that. So 50% returns 48 bytes or more in the actual response. So it's not catastrophic, but it's not ideal if you really want to do troubleshooting deterministically. So let's compare the two, right? So we have stateless on the one hand and stateful on the other hand. So in stateful, we, for example, we record the time when we send the packet locally, and then if it's not being returned to us in the ICMP time exceeded message, we can just calculate it, right? So this is the state I'm talking about. It's not a lot of state, it's not difficult to maintain, and it's easy to protect and remove, but it's there. So for the stateless version, we can identify all the routers on the reverse path, the IP address of the routers on the reverse path. Stateful can do that too. And as I just showed you, we can't always estimate the RTT because sometimes the time exceeded message will be truncated too early, and we don't get enough information back. But in 50% of the cases, this will work. For stateful, this will always work because we keep that information locally. And in addition, there's a function that a couple of operators have asked for. They found that useful. So what we, in the stateless version, can only do, we can trace back to the requester, because the copy of the IP header will be in there, so we know where to respond. A couple of operators asked, well, can't we just ask somebody else to trace somewhere completely different? We could, but we need to remember this, because this will clearly not be inside of that packet. So a stateful version will give you extra information. It's a bit like this website. Is this blah, blah, down for me or for everybody else, right? This would be a similar function just for traceroute. And there was interest in that. We can't do that in stateless, but we could do that in stateful. So that's why we submitted stateful before we submitted the stateless variant for you to consider. In all fairness, there's a little bit of amplification, right? So we send a request. The server is going to do a probe. So it's going to send out a single probe. It's going to receive potentially a TTL expired back. And then it also sends a reply back. So it does a little bit more work than, and it sends a little bit more than the client is actually sending. So there's a little bit of amplification. If you want to attack the internet, I would suggest DNS still, but there's a little bit of amplification. What you can do against that is, and there's an extension in the draft, you can make the client send way more bytes before you actually start the reverse traceroute operation. All right. So I also asked for working group adoption. I think the document is in pretty good shape for an individual document. No offense, but I think it's in pretty good shape. We have an implementation of it. So the server we have as an eBPF program, the client we have as a Python script. You can download it, it's online, it's available. I can send you the links if you want to. They're in the presentation that Valentin did in Prague. We also did a bunch of measurements to see which code points to use. We sent it through a bunch of nuts to see how nuts are behaving. We looked at the RIPE Atlas data to estimate how well stateless would perform on today's internet. So I think we have a good package to decide whether we want to adopt this as a working group item or not. And I think we need to agree on two things. So the first thing we need to agree on is whether we think this is a function we want to give to the operational community on the public internet. And the second thing, we need to decide if this is a good starting point as a solution. If the document gets adopted, I already have a plan for it. So I personally would call it reverse traceroute, so remove the stateless. And then I would leave it up to the server, so that the server, or the operator of the server made a conscious decision to give you the ability to use reverse traceroute with his box. So when this person did that, we can actually leave this person the decision to whether to do it statefully or not statefully. So after it gets adopted, I would suggest that we offer both as a solution, because the signaling doesn't change, right? So you ask for it, it's being done. You don't know how it is being done, if it's statefully or not. The server can decide, and then the worry about potential security issues with the state, we have to address obviously in the document. We did in the stateful version, and it's up to the operator of the server to actually decide whether they want to offer it statefully or not. This is what I would do.
Okay,
right?
thank you very much. You have 3 people in the queue right now. Nalini?
Yeah, Nalini Elkins. So one of the things, I mean, it's great idea, because I've certainly wanted it myself, you know, having a reverse trace route. The only problem though is like so many people, so many routers block ICMP on the internet.
Yeah, they probably do, but we don't talk to routers via ICMP. So we talk to end hosts. And so we did some measurements. So if we sent, I think, ping, a simple ICMP ping to, I think, 10 million hosts on the internet or IP addresses on the internet. And when they replied to the ping, so we know that ICMP goes there, we sent our messages there as well. And most of them responded to that as well. So there's a big chunk of places on the internet where this works today. So I don't think we have to worry about that.
Huh. Okay.
We have a paper about this too. I can send you a link and then you can see the numbers yourself.
No, sure. I mean, every time I've done traceroute, there's a ton of stuff that doesn't respond back to ICMP. So.
Well, so it depends. So if you use the macOS or Linux traceroute version, it's not even ICMP packets that you send out. It's all UDP packets, right? And they don't respond for various reasons. It doesn't have to be because it's ICMP. It could be because they're rate limiting time exceeded messages and things like that. So it might not be related to ICMP.
David Lamparter. From scrolling through the draft, it's not entirely clear to me whether this is intended to be deployed on a huge amount of routers or end hosts everywhere, or whether this is going to be a very targeted thing that gets deployed in a few places. And I do think that distinction matters, at least for the security considerations section. So I think it just needs a little bit of clarification.
So I can clearly not control where it's going to be deployed, but I would assume for the security considerations, let's just assume it's on every host on the internet, just like ping is. But it's ICMP, right? So it's going to sit in the kernel. So let's go with that assumption and write the security considerations for that.
So at the very least, I think you need to answer whether this is a default on or default off feature if I have a box that is fresh out there.
Yeah, I completely agree. Yeah.
Thank you. Eric?
So Eric Ving, Cisco, pretty much like David, right? So I think your explanation is much clearer than in the draft. So thank you so much for the explanation here. If you start a traceroute from a server on the internet, you will install a state because you need to correlate the reply or the absence of reply back to the host. So it's not really stateless, right?
This one is stateless because it's all in the packet. So we send the probe out, and when we get the time exceeded back, all the information we need is in there.
Okay, it's not how I understand the traceroute. Same, because you need to remember I'm sending this UDP probe to this from this port. Then when you are receiving back, I need to now understand, oh, it was my destination UDP port. I need to remember it. Okay, whatever. The other point, I really wonder whether ICMP is the right protocol to be used rather than netcon for something like that.
I would say yes.
It could give you authentication in the same shot.
Right, but I would strongly argue for ICMP is the right thing to do because so I would like to have this as a utility for the public internet. So on the public internet, we have two things, right? We have ping and traceroute right now. There's nothing else you have. You don't have netconf on the public internet. You have that for your boxes. The same is true for SNMP and other management protocols. It's for your boxes, but I want this to work on the public internet, and then ICMP is the right answer, I think.
That's the point. Thank you.
Ben?
Hi. So do I understand right that you can request the traceroute server to perform traceroutes using UDP and TCP?
Or ICMP, yeah.
Or ICMP.
Yeah. But one request only triggers a single packet.
Right.
Yeah.
But I can only use ICMP to communicate with that server, right?
The request will be ICMP and the response reporting the results will also be ICMP, yes.
Right. So this strikes me as odd because the number one reason I would use UDP traceroute is because of ICMP black holing, right? But this actually doesn't allow me to function in the face of ICMP black holing because the outer connection is limited to ICMP.
Yeah, that's true. So the motivation for that was you could also write an application that uses TCP or UDP for the signaling, right?
Yeah.
But that means somebody needs to install that application, and we wanted to have it in the kernel, so it's a facility that's just there. Comes with the operating
system. So I
think
there is precedent for kernel integrated services that are listening on for UDP and TCP in ancient history, at least. I think like the echo functionality on I don't know, port 7 or something. So anyway, I would consider whether there's potentially a UDP endpoint that you know you could allocate an IANA port for this, and that would help.
Yeah. So one response to that is that there's an applicability draft for RFC for ICMP. So for what kind of functions can you use ICMP and for what you shouldn't use ICMP. And network troubleshooting is the thing that you should use ICMP for. And this is basically it's fitting so nicely also for the applicability of
I think
ICMP.
ICMP should exist, but I'm not sure it should be the only way.
Yeah, all right. Yeah, point taken.
I also do wonder if you could get some RTT information by using a deeply truncated timestamp to try to get that, squeeze that information into the first 8 bytes.
Mm-hmm.
Thank you.
All right,
Thanks a lot. Lynn? Please.
Okay, hello everyone. My name is Lin from Tsinghua University. Today, I'm going to introduce the update of our draft a service solution for wireless LAN. First, let's take a recap of our draft. SAVI WLAN is a source address validation solution for wireless LANs. It uses MAC addresses secured by 802.11i or other security mechanisms as binding anchors. It performs ND snooping or DHCP snooping to bind an assigned IP address to a verified MAC address. It specifies how to migrate SAVI bindings in mobility scenarios. And also it supports 2 deployment scenarios. In centralized wireless LANs, both access points and access controllers can filter the spoofed packets based on the SAVI bindings. In autonomous wireless LANs, only access points perform the filtering of spoofed packets based on the SAVI bindings. Okay. Since the last time in IETF 119, we present this draft, and there are many people who are not who were not very clear with the problem and motivation of this draft. And this time, I will focus on explaining it. First, let's talk about the problem. There are 2 problems we think in the wireless LANs. The first one is there is a lack of naturally available binding anchors in wireless LANs. In wired LANs, people use switch ports as binding anchors. However, they are secure. Yeah, they are secure and more difficult to spoof than IP addresses. However, in wireless LANs, there are no switch ports. This kind of naturally available secure binding anchors. So that's a problem 1. The second problem is that in wireless LANs, there are wireless LANs suffer from the problem of user roaming. Yeah, when a user moves to a new access point, there is a lack of appropriate binding entries for source address validation. So we need a solution for wireless LANs. In fact, FCFS SAVI, which is RFC 6620, considers a user roaming case and uses a neighbor discovery protocol to verify that the host is still reachable through the previous binding anchor. If not, FCFS SAVI assumes that the new location is valid and creates a new binding using a new binding anchor. Otherwise, the packets coming from the new binding anchor are dropped. However, we find that this solution does not solve the source address validation in wireless LANs very well. there are two limitations. The first one is ND probing against a previous access point increases the waste of air interface resources because the host can no longer receive packets from the previous access points when the user roaming occurs. And the second one is the use of ND to confirm whether a host is still reachable under a previous access point prolongs service outages during host roaming and negatively impacts user roaming experience. So we believe a new method is needed for fast migration of savvy bandings under wireless LANs. And we have updated the document since IETF 119, and there are three major steps. The first one is the consideration has been given to the validation of IPv6 address prefixes obtained from by host through DHCPv6 allocation. We have updated the related text in version 003, and there is not a much difference in the way that the prefix are handled. The second one is we have made the modification to the capwrap message element format. This message element is used to synchronize savvy bandings between access points and access controllers. More detailedly, we simplify the fields in the message. We remove sender ID and its length and the description from the message. This kind of fields were originally designed to identify the message sender. But since we can the access the message sender was is access points and access controllers. Since access points and access controllers can directly process a message after receiving them, so this kind of these fields are no longer available, necessary. And we also provide support for migration to the prefix related savvy bandings. In the bottom of the figure, we provide some fields. Third, we add a consideration of the impact of different random MAC address generation methods on savvy wireless LAN. We believe random MAC addresses do not affect the functionality of savvy wireless LAN because hosts are not allowed allowed to change their MAC addresses during transaction exchanges according to HV 802.11i. There's another issue is the relationship with existing savvy solutions. For different address assignment scenarios, the method of establishing banding entries still follows respective scenario-specific procedures. For example, RFC 6620, RFC 7513. That's all. Any comments? Thank you.
Thank you very much. Any comments? Okay, we don't have anyone in the queue, but if you have any comments, feel free to submit on the mailing list or request more feedback.
Thank you.
Thank you. All right. So,
can I just?
Yeah, one, Eric.
My understanding is that your document extends CapWAP. Okay, did you consider presenting this document in ops EduVG, which is basically the ops area, because CapWAP was ops before? Okay. The chair is over there, just next to me.
Okay. Next is Josh.
I don't know how to do that. So can you just run the slides for me?
Sure.
So I'm Josh Cohen. I'm can I lower this? Is that okay? All right. The perils of being short. So I'm one of the original co-authors of WPAD, the Web Proxy Auto Discovery, which I think everyone here has heard of, or and if you've been on the INTAREA list over the past couple weeks, there are a bunch of discussion on that. And so that was designed 25 years ago before DHCP was even widely deployed. So the choices that we made are probably very different than what we would today. And one of the choices, I think, I've discussed this with a number of people over the past couple of months, and I think there are really two schools of thought. One is it's over, basically just put it to bed. It's no longer something we should continue to do. And the other, which is, I will admit, a minority view, is to constrain it, is to make it less bad, I guess. For those who think that network discovery or proxies is inherently bad, it's less bad. But I think one of the questions that needs to be answered, like some operating systems have it disabled by default, but Windows does. And so see, is Dragana still here? Yeah. So we've been talking, and one of the things that needs to be figured out is that because IT admins are still, enough of them are still using it and want it, or is it just kind of there because it's there? So I think one of the things that needs to be answered going forward is what is the situation? So for the moment, what I've chosen to do is to try and slim down WPAD and see if that is an alternative solution. And at least that way, whatever we decide to do, there's choices. So next slide. So the current draft deprecates a few of the discovery mechanisms that we had back then. The most problematic, I think, is the DNSA. Combination of using WPAD as a host name combined with the DNS domain devolution, which is where you start with, let's say, sales.example.com and then go to example.com if you don't find it. And that has led to probably the most extreme exploits that I've seen. So getting rid of that is good. Back then, DNS text was barely adopted as well. And the answer, as we saw it, was server location was going to be the way to securely discover services on the network, but that ended up not ending up the same way. So what remains is DHCP and DNS SD. I've been talking to people about the different potential exploits for that. And from config file format, pack file is a problem. That's where a lot of problems also happen. It's also very complicated, and a lot of resources get used because it's clicked. It's run every time a browser link is clicked. So an alternative to that is PBD, which Dragana presented on earlier. And also, and one of the ways to deal with rogue advertisements of proxies is if an enterprise does not have a proxy and wants to make sure that rogue proxies don't interfere, add a URN to the answer that you can get, which just says none, which should stop discovery. Looking forward, one of the things that I'm considering, and I would appreciate feedback, is to just get rid of the devolution thing altogether. I think one of the things that I'm curious about is, I mean, that's a DNS SD thing, because that would be a situation where you may have a subdomain where the DNS SD is responding to that, and then there would be a parent domain. But if we get rid of DNS SD, that answers that problem. DHCP only is another way to go. And another, which I think would be helpful, is to require user consent. I mean, that was kind of a choice back 25 years ago that was really more about, we didn't have a good way to do it from an architectural standpoint, because the HTTP engine was on a different thread in IE. But nowadays, when you get on a Wi-Fi network, there's often the user sign-in screen, so that might be possible, and that would help alleviate things as well. Any questions or comments?
Okay, thanks. Chris?
Yeah, it's not my area of expertise, but just have you considered mobile networks because they don't use DHCP at
Have
all?
you considered what?
Mobile networks, cellular. They get allocated IP address via data connect, PDP context create, and they get given IP addresses for DNS, but that's about it. So as far as I know, DHCP is not part of that the setup chain.
Do they have like an equivalent?
Well, DNS.
Like SD?
I don't know. That would be an area to explore.
Okay. Can I talk to you about that later?
Yeah.
Okay.
Yeah.
Thank you. Ben?
Ben Schwartz. So the original WPAD was a draft that never reached RFC. It was never approved by the IASG, and it was stacked on top of the pack file concept, which was also a proposal that was never actually standardized. And so I feel like we're trying to like update a thing that actually never in IETF terminology was created. So I don't think we need to modernize it just because it's old. When it was never a standard in our formal terms to begin with. And I really feel like what I'm missing in all of this conversation is the why. Like, why does this even? Why are we even talking about this? Like, why would a network need to tell me these things? And like, okay, maybe there's a good reason, but like, we need to know the reason to design an appropriate mechanism. So it just seems like we're working in a vacuum here, and I can't make any of these choices without knowing a lot more. The thing that I don't see, or at least not explicitly here, is the option to take classic WPAD and just restrict it in various ways, essentially deprecate portions of it and leave whatever we believe is actually useful, and then potentially elevate that to a proper RFC steps.
Okay, so I'm going to respond in reverse.
Okay.
So I think to your last point, I mean, that is what's here. This is the old WPAD draft with like cross this out, cross that out, and add a few things. As far as the question of what is the reason, one of the things that we need to do an assessment of is, back then we had a set of reasons, and now the question is, are IT admins still really using this, and why? And so that's a conversation that is coming. I mean, I can speak to the decisions we made back then. I mean, part of it was, proxies were relatively new, and they weren't necessarily viewed in a positive way. But in order to save the lives of help desk people, having to constantly tell people how to configure their browsers at a point when they were still figuring out how to do use the browser on a PC with like WinSock, so it was just it was an obstacle to enterprises getting their employees on the web. Like, I first started thinking about when I worked at UPS, we were designing a proxy to allow browsing from a desktop, and we had to integrate with the mainframe for single sign-on because management wanted authentication logs, and that wasn't yet in HTTP 1.0. So that's why I ended up coming to the IETF. So the question is, okay, what is the world like now? And I think to your first point, when there's been a series of vulnerability announcements, and when I spoke to Mark Nottingham, the HTTP chair, he was like, "Oh, this is the perennial question of what do we do about WPAD?" So whether or not it actually achieved standard status or not, it's like, okay, well, let's answer that question.
Yeah, I think that there's a real opportunity here for an informational draft on architectures, like network architectures involving proxies. And it's far from just enterprises. There's a bunch of performance enhancing proxy architectures that are in wide use. There's a bunch of new multi-hop proxy architectures that are emerging. I kind of want to see that all really thought through before we go try to make something.
Yeah, I think I'm being played off.
Yeah, please take it offline. Thank you very much for the feedback. You don't see. Okay, próximo.
Okay. Yeah. Hello. This is like illustration of great minds think alike because it's very similar to what Bill presented. It's very similar. We might need to merge it, but let me talk through it first. So next slide, please, because I can do it from the phone for some reason. Yeah, so let me first talk why we doing this, why I'm here. No, not this one. Anyway, I'll talk meantime. So I spent quite a lot of time recently on doing V6 only or V6 mostly networks, right? And I will, yeah, next slide, please. Actually, next slide. So yeah, this is a quick refresher how V6 only done. Normally, right, you have NAT64 somewhere in your network which connects your V6 only network to the dual stack of only internet. But the most interesting part here is to make it really deployable on a random client, you most likely would need CLAT, customer-side translation, which will take your VFO-only application traffic, translate it to V6, and send it on the wire, and translate the return traffic back. Next slide, please. So what's the problem here? Let's say I do trace route from my V6-only MacBook, which sits on IETF network, to some V4-only destination. Let's say I do trace route 8888. Routers which are in the internet, which are dual stack, will respond from the V4 addresses to some NAT V4 address, will be translated to V6 by NAT64 PLAT device, and that ICMP V6 will be easily translatable back by CLAT because the source address of that ICMP belongs to NAT64 prefix. However, what about a trace route from the intermediate hops which are between the client and NAT64 device? Those hops are actually V6 only, and those V6 addresses are untranslatable fundamentally because the real V6 addresses, they are not from NAT64 prefix. So as far as I know, most implementations drop them. There are some exceptions. Next slide, please. So yeah, as I say, observed operational issues is that trace routes could not represent V6 only hops, which confusing for users because they're telling you, oh, you have a packet loss in the network, which I actually don't. And it's obviously complicates troubleshooting. Another case is it means your packet too big are not translated. Well, theoretically, I had a lot of conversations this week. Theoretically, maybe you are not supposed to have MTU problem in your V6 only network. You should be thinking about that. And if you have MTU problem, you're doing something wrong. But well, sometimes I guess your backup link might be through internet or something. Anyway, I think it would be nice not to break pass MTU discovery even more. It's already broken enough. So next slide, please. And next slide. So what we are proposing. We'd like to define how to translate untranslatable. I mean, V6 addresses which are do not belong to NAT64, and also preserve the information about original V6 source. Next slide, please. And now how? Next slide. First of all, let me define untranslatable because I don't want to repeat it every time. So when I'm saying about untranslatable addresses, I'm talking about addresses not from NAT64 prefix and for which translator doesn't have an explicit static entry. Next slide, please. So yeah, translated and translatable. Yes, there is a .8 address, which is dummy v4 address allocated by Anna already. It's kind of, I think it kind of belongs to 4RD, so yeah, we might use it, or we might just request to one particular specific address just for this purpose. And yeah, suggestion is to use that address to translate the source IPv6 addresses if they are fundamentally untranslatable. Android implementation, as far as I know, for traceroute using 25500X for traceroute and use TTL as X. So your hop number 2 will be seen as 225002 in traceroute. but obviously it would be nice to standardize the approach. So especially because we are in the process of writing a draft for how CLAT should operate on hosts. And this is actually important addition to CLAT implementations. Next slide, please. So yeah, so what we proposed at the same time as Bill wrote his draft is to introduce a IPv6 original source extension object. It's obviously much simpler than what Bill's draft doing. It just a length class and 16 bytes of original source IP. Next slide, please. Yes, so obviously we want to add it. It should be added by translator, I mean by CLAT, when translating v6 to v4, and obviously when only those conditions are met. Packet too big, special case, I'll talk about it in a second. Next slide, please. So I mostly want to hear the room feedback on should we before how. So that's why I intentionally do not put details on the draft. But in overall, a draft has details about when and how to add the extension structure by translator, or how to add that structure to existing, this extension option to existing structure. Thank you, Bill, for feedback on missing points here. And we'll also update an actual translation algorithm on how it should be done. Next slide, please. So open issues, actually. Currently, draft suggesting that extension object is added to v6 packet and then translated to v4. I guess it's kind of easier because then it's easier to check if the translations actually, if the extension object should be done. However, it means that we cannot add it to packet too big because extensions are not defined for IPv6 packet too big. If you translate first to v4 and then add to that extension structure, it means packet too big can be properly translated and extension structure can be added, but I don't know how easy it for implementation to remember all those v6 details because they theoretically should be done. Actually, I got some feedback in the lobby that maybe we are over-specifying and maybe draft should not be even talking about that. It should say what we should get as a result and do not talk about all details like how to update checksum, where to add, or just maybe provide an example. So it's actually also feedback I'd like to hear. Next slide. Oh, it's the wrong version. Anyway, yeah, so basically I have a slide here. So there is this, we can merge it with build draft, right, maybe, and add details about how to translate. There is original RFC, which I also can't remember the number, about source address extension, whatever it's called, which builds draft kind of using as a base. However, that RFC is saying that we will be violating it because it's saying that if original interface, if the ICMP is ICMP-v4, that structure must be IPv4 address, and if ICMP, if we're talking about ICMP-v6, the extension object must be IPv6 address. So it will be violating of that RFC to adding IPv6 address as an extension structure into ICMP-v4 packet. So it's actually, I don't know, like again, I don't have opinion. I'm happy to merge with Bill's draft if Bill is happy, or we can keep it simple and separate in this one. So this is all I have.
Okay.
So feedback,
Thanks.
please.
Unfortunately, I think we're out of time, so we're going to allow, well, one quick comment, but otherwise we need to move on to the last presentation.
So quick comment, it's useful. I would suggest that you use Bill draft and you continue on it.
So you suggested merging.
I'm not sure whether you can really merge them. Well,
you suggested like using extensions defined in Bill's draft and
you use it, yeah. You have a normative reference to Bill.
Yeah.
Wait, to be decided, right? As an individual or contributor here.
Okay. Masanobu, would you mind sending your comment to
I'm Masanobu from NEC.
Can you send your comment to the list because we have one more presenter?
Okay, I'll talk about you later.
Please, sorry. 1 minute, Shangfeng.
Okay, can you hear me?
Yes.
Okay, great. I'll give a brief introduction about these slides. Yeah, this is about Even 6. Next, please. Even 6 layer 2 network model built on top of the IPv6 analyte to provide connectivity between discussed sites. So this draft is not new. It has proposed before IETF 118. So it discussed for many rounds. Next, please. Yeah, this is architecture and the function model of Even 6 adapt in PE devices. adapt encapsulates the frame from the customer site into IPv6 packet and send them to the IPv6 only network. Then the egress PE remove the header and restore the original layer 2 frames. Even 6 uses 32 bits V to identify each instances. And for each Even 6 instances, adapt use the IPv6 site prefix to identify each site. So different sites have different prefix. MAC address table is a INP to store the MAC addresses of all the hosts and the corresponding V and set prefix they belong to. Next, please. So for layer 2 frame to be transmitted, it is directly placing payload IPv6 packet by the adapt egress PE, and the field of next header is set as 143, indicates that this is the payload of the Usenet frame. Next, please. So this is about the address generation by mapping and by the egress PE, and there's 3 inputs. They are the MAC address of the host V, that is virtual network identifier, and the set prefix. So whether it is source or destination, each MAC address will be mapped to one out IPv6 addresses for the encapsulation. So this has been discussed in the last IETF meeting. Next, please. So regarding to the control layer, this has been mentioned by Eric. So the companion control layer document will be submitted after IETF 120. Next, please. The following revision have been made since IETF 119 based on the suggestion of Eric. Multicast in Even 6 added in section 5.1, and the section of broadcast is revised in section 5.2, and GB Sun is added as one co-author. Next, please. And based on the comments of Eric, we also added the section of justification and benefits analysis. Since this approach leverages advantage of IPv6, so it is different from legacy approaches. This advantage has been illustrated in last IETF meeting, so I don't want to read the introduction again. Thank you. Next, please.
We're running out over time, so if you can close in the next 1 minute, please. 1 minute, please.
Okay, sure. Next, please. Yeah, this we have implement system and set up a test bed to test capability. Next, please. Yeah. So within each Even 6 instance, we can ping the host from one to another. We can ping P1 to P2, P3 to show the capability of Even 6. Next, please. Yeah, we can even transfer the file from one host to another within the Even 6 instances within the same over IPv6 analyte. Next, please. Yeah, this is for file transfer. Next, please. Next, please. Yeah, this is a snapshot frame mapped IPv6 packet. We can show that the IPv6 packet by the approach proposed in this document, including address generation and put the frame into the payload. That's all. Next, please. Yeah, Even 6 is a virtual network, so it has the isolation capabilities. So in this case, H1, H2 belong to different cases. So belong to different instances. So H1 cannot ping H6. So this shows the isolation capability of Even 6. Next, please. Yeah, so we also would like to ask for working group adoption this document, and any comments, suggestions are welcome. That's my introduction.
Okay, thank you very much. Unfortunately, we're out of time for questions, but to the working group, send your feedback on the mailing list. And I also encourage you to ask questions if you have any to the working group on the mailing list.
Okay.
Thank you very
Thank
much.
you.
Thank you very much. Thanks, everyone.
Thank
I'm sorry about running on. Merci à toi.